Hello, my name is David Riley, and this is my video demonstration for Challenge Assignment 1 for ECE 461, Erasing and Writing to Flash Memory. The hardware we're using is the MSP432 Launchpad, and the object of this code is to erase and write to flash memory once every minute while having a watchdog timer for 1 second that resets the system. So first, let's get right down to the code. First thing we do is we configure the watchdog timer. It's set it to a hard reset. Configure the clock source and divider to give it a 1 second interval. And then we hold the timer and disable any interrupts while we configure the rest of the system. So then we go to this function here, port init, which will be dealing with the three GPIO values that we'll be using this function. We have a red LED, a green LED, both those are set to output, and then of course we have a switch input that can be used for a manual reset. So those are all configured in this function here. If we go back up to the main function, it then does some more housekeeping instructions, setting the voltage level and the wait states for the banks. We will only be using bank 1 for this code, but it's already set for both. We allow for faster programming by setting the M clock to 48 megahertz. And then we actually get into the actual program itself. So we start by turning on the red LED to indicate the system has started or restarted. And we have it on for a second before turning it back off. And then we jump into the while loop. But before we do that, we of course enable the watchdog timer and any interrupts for the system. Now, this while always loop that we will be in for most of the program only has one function, that is the erase and program flash function, which does a majority of the work. So what this function does is we will take this value here, 0xDA, and we will be writing that to our flash memory. Notables is that we will be starting at bank 1 sector 0, and this is the starting address for that. Each bank has 32 sectors, and each sector is offset by this value on the address 0x1000. So this is the address for sector 0. If you replace that 0 with a 1 there, then you will have the address starting address for sector 1. So first we of course unprotect the sector. This value here is generally meant to be a specific sector value, but instead we give it a sector mask as defined as such here, which basically enables all 32 sectors at once as opposed to going one at a time. Then we mass erase all of the unprotected sectors in the system, and then we write to each sector one at a time because there is no mass erase functionality. You can only mass protect or mass erase. So it does that 32 times with the first address, and of course offsetting to the starting address of each sector every time it runs through the program. Then of course, after you unprotected the sectors, you need to reprotect the sectors. We apply the same mask as before, so it protects all 32 sectors in the bank at once. Then, to show that we have completed the task, we turn on the green LED for 1 second here. And of course, during any of these major loops, like during this delay here for the LED or during the writing function, we of course always clear the watchdog timer to ensure it does not reset while we are performing a task. So after we have the green LED turn on for 1 second, we then have this second delay here because the system is only supposed to erase and write for once every minute. So this delay holds the system in place until a minute has passed, and then the function ends and it returns to the while loop and starts the program all over again. So it will stay in this while loop for the remainder. Because there are no errors, the watchdog timer will not naturally occur. So to make it manually occur, we have the button reset interrupt down here, which detects whenever the button has been pressed, and when it has, it will redirect the function into an infinite while loop where the watchdog timer will indeed eventually reset the entire system. And it'll indicate such to the user by reflashing the red LED before the while loop. Now let's go ahead and jump into debug for the system. Okay, now we are in debug mode. As you can see in the memory browser, I have already started the set the memory browser to the starting address of bank 1 sector 0. And for debugging, we will just demonstrate that the program does in fact erase and write to the flash memory. So we can just jump straight ahead to our erase and program flash function. We're going to be adding breakpoints, one here at perform mass erase, one here at the clear watchdog timer function within the writing while loop, and then one more here at the protect sector line, which occurs after all the sectors have been written to. So if we go ahead and we just run the function as it is with those breakpoints, it'll naturally, of course, stop at the first one, perform mass erase. Now, mass erase won't appear to do anything at the time because all of the addresses here have already been erased. So that's why we put the next breakpoint here, so we can just skip ahead to show that it will in fact write to memory as shown here. So now instead of FF for all of these values, they now have DA, 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 because that was the value we told it to write to the system. If we jump ahead to the starting address for sector 1, you can see none of those have been written, but if we scroll up and look, sector 0 has indeed been written. So if we run it again through the loop, sector 1 has now been written to, and sector 2 onwards have not yet been written to. So we're going to go ahead and remove this breakpoint just for the sake of time, and then it's going to take a second while it writes to the remaining 30 sectors. Any minute, there we go. And so you can see now it's DADA for all of them. So if we change the address again to the last address of sector 31, you can see which is there. So now it is, it has written to, in fact, all of the sectors in bank 1. Now if I'm going to jump ahead because I want to prove that it actually erases when it's supposed to, but instead of waiting a minute like the cycle will have you do, I'm just going to cut here and resume when the system has passed a minute. Okay, so we are back and the minute has now passed. So as you can see, it has stopped again at the perform mass erase breakpoint. I've gone ahead and reset the memory browser back to the starting address for bank 1 sector 0. I'm going to change the next breakpoint to this line here before it writes to any memory, so we can show that it actually erases all of the sectors. So if you look and you see here, it's still at DADA for all these values for all these sectors. So now if we hit go, now all of these values have been, of course, replaced with FFFF for all of the sectors. If we do the same thing we did last time, go to last address, and you can see these are all blank now. And of course, jumping back to the starting one, if we just run it so it writes one sector, now sector 0 has been written, and only sector 0 has been written. So that proves that the code does in fact erase and write to the flash memory. This concludes the debug portion. I will now jump ahead to the hardware demonstration portion. Alright, for the hardware demonstration, you can see here the MSP432. It is already plugged in and has the program already installed on it, but just for demonstration, I will re-debug and download the system. So you can see the red light comes on showing you it has begun downloading. And now it is ready to be debugged. I am removing all the breakpoints in the system, so you can just see it run in its entirety. So first, when the system starts, it'll of course turn on the red LED indicating the system has either started or been reset. And shortly after, the green LED will come on to indicate that it has successfully erased and written to the flash memory. So there's a red LED as the system starts, and then it takes a few seconds. for the green LED to turn on. And there it goes. It has successfully erased and written to memory. Now the green LED will not come on again for another minute. So instead of making you sit through that minute, I'll just show how the interrupt system works. So we can look over here to our port 1 pin 4 switch. So if we press this, the red LED will come back on, indicating a system reset, and then of course it'll trigger the green LED after a few seconds again. Yes, and I can just show that no matter where in the system, whenever I press this button, the red LED will turn on, indicating that the system has in fact been reset. This has been my video demo for Challenge Assignment 1 for ECE 461. Thank you.